All right, so everybody can hear me, I assume, because I can hear myself. So that's awesome. Thank you so much for letting me come and talk. This time I'm going to talk about embedded CDNs, and the reason I came up with talking about that at all was that I realized last year, it was 10 years ago, that I was chairing a panel at NANOG and basically yelling at the CDNs because at that time I was working with our everybody's beloved TDC, and we were deploying Akamai servers. We had Google caches. We knew that those Netflix people would show up at some point. And I thought it was just like, oh man, they're all doing it differently. Like some of them needs to be done in one way. Some had one kind of power. The other one had another kind of power. The servers are not the same size. So every time you had to do a new deployment, there was a lot of research needed to be done. And then at some point, you needed to understand how traffic steered to the caches. So at that time, I was yelling at them, talk to each other and do it the same way. And so I set out to try and figure out, are they doing it the same way today? And if they're not, is it a problem? Or just in general, who's out there now? Because I was thinking at that time, oh my God, that's 3, 4, 5, 6, all different type of servers sitting inside my network. So I ended up with this talk where I'm sort of diving into who are there, a little bit of statistics, and a little bit about how do they work. And then finally, what to think about if you want to deploy them inside your network, what can you get out of it, and what do you need to look out for if you decide to deploy them deep into your network. So let's get started. First of all, just to make sure we have the definitions right, what is a CDN? If you go on really a helicopter view, it's just a bunch of servers sitting in a distributed geographical area. And then it's a method to put content on the servers. And it's a method to get the end user, the consumers of the content, routed to the right server. And when we talk about embedding, it is when you put those servers inside ISPs networks where they're using IP space, or at least IP space, if not from the ISP, then from originated in the ISP's ASN. So you're not seeing the CDN as their own network, but it is suddenly a part of somebody else's network. And finally, they're aimed for serving the customers of that ISP only and not everybody else on the internet. And finally, the last definition I'd like to get that I will be mentioning randomly throughout the rest of the presentation is a cluster, which is basically a collection of servers that are sharing their disk space. So when you have a number of servers in a cluster, you look at their combined disk space as one disk. So the content will be spread over different servers and not available on all servers in the cluster. Any questions on that? There's going to be a pop quiz in the end. All right, cool. So also, the CDN market has developed quite a bit the past 10 years. So we started out building CDNs because the content became richer. We had pictures. Those of us with gray hair remember that when we were looking at a website, then the picture would load, like, it would come down very slowly. You new people, young people, students, you will not know what that is, how that feels. It feels bad, I tell you. And that is why the idea came up. Let's push the pictures, the videos, let's put it close to the end users so it doesn't have to travel as far over the internet to load. Akamai, one of the oldest, came up with a brilliant algorithm to put the content and get the folks to the right content. And then we have some of the legacy CDNs still sitting at Lumen, Tata, Edgio. Very well established, doing good business today. And then we have the newer ones, Cloudflare, Fastly, and StackPath, which have come up by offering a more specialized type of CDN with more security focus or DDoS protection or specific high performance for specific type of content. But we have to also give credit to the old guys like Akamai that they are following on the market and are offering all these services as well. And finally, so basically, what we see also is that people with a large amount of content, they're using CDN services, are often using more than one. So they can leverage the different types of features they have or the geographical scope that will be there. So one example of that is Disney. They use a lot of different CDNs, so you'll get that service from all over the place. Finally, the giant content producers like Netflix, Apple, Microsoft, they've decided to build their own CDNs because that way they can optimize the service specifically for their content and are not driving the build out of the commercial CDN. What can happen is that if you have so much content that these guys have, you will be the main or the most important customer of a commercial CDN, but also all the cost of the development will then be on you. And these guys figured out it would be easier to do it themselves. Yeah. And then finally, what we're also seeing in the market, I think these days, is that the CDNs are looking more to cloud services and compute, so they're adding that type of service to their feature set. And at the same time, we have the big cloud providers also provide CDNs, partly for their own service, but also selling the CDN to other people. So there's a merge as well happening in the market between cloud and CDN services, which I think would be interesting to follow. Okay, so who's doing the model of actually placing the servers inside people's network? A lot of the data, or a lot of the claims that I'm going to come up with on the next slides are based on an analysis of data, traffic data from a part of the internet that I have access to, which is the Kentik customer base, who have allowed us to do analysis on their traffic. So it is a sample of the internet, very heavily skewed towards the US and LATAM. So it is how are things looking in that part of the market. But it gives at least an idea about where we are there and where maybe the rest of the world is happening or is going. So just bear in mind what the data it is in the next couple of slides. So we see now the same ones that I was yelling about 10 years ago, Akamai and Google and what was the third one? Yeah, and Netflix coming up. But we also see that Amazon, Facebook, Cloudflare, CDN 77, Microsoft, Apple, Quilt out there, and even some that I don't really know what is, so I haven't put them on the slide. But those are the people that we saw in our customers' network. And if a little bit more statistics, if I look at the number of customers who had embedded servers, most of them would have 6 or less. So even though there is a higher number available, it would be typically 6 or less. And again, the top deployed was that 25% of the ISPs in our sample that have an embedded server will have one from Google. 26 will have one from some from Netflix. 16% will have some from Facebook, and so on and so forth. So it's almost the FANG guys, but not completely. If we then take a look at the traffic in our sample, that is marked as CDN traffic. Here's a split of how that traffic is coming into the customer's network. Is it coming, 4% was coming over the network border. 14% was coming from embedded servers. And mind that this sample is all of the customers, both those who have embedded servers and those don't. It's just a general look at traffic marked as coming from a CDN in our data set. 7% is from embedded to embedded server internally, and then 5% externally and into the embedded servers. All right. Then I'm going to take a look at the four biggest ones and see how is the traffic coming from that CDN split in outside to end user, embedded to end users, outside to embedded, and embedded to embedded. So if we look at Google, and here we're looking at the ISPs who have one or more Google servers in the network. The aggregated statistic is around 40% coming still from outside of the network. And 56% coming from the embedded servers to the end users, 5% filling the servers from outside, and 1% going from the internal servers to internal servers. For Netflix, we have a way higher amount of traffic coming embedded to end users. And also a note that we have a higher going from embedded to embedded. I'm going to talk about why that is a little bit later. Facebook, Akamai, again, we see how it varies. And this is just basically statistics. It doesn't say anything about how well these CDNs are working, because some of these people may have not enough capacity on their servers. Maybe they're just in the process of doing it. But I thought it was an interesting comparison to look at anyways. But mind that it doesn't say anything about the efficiency of the CDNs or the embedded solution. So to take a step back from traffic statistics and traffic flow and have a little bit look at what are the different methods that could be used to direct the end user to the server. One way of doing it is using BGP. It is very common that an embedded solution have a BGP session from either a cluster or from each of the individual servers that you are embedding, or just maybe a single BGP feed from you to the CDN. And what is signaled on the BGP session? Usually, it is the subnets that are allowed to be served by this cache or by this embedded solution. It also, some of the CDNs will allow you to signal your preference of, well, these servers should be preferred by this group of users. And you can, is that a hand? Do you want to say? No, you don't. Just stretching, sorry. Got to start over. Some CDNs allow you to use BGP to signal to the CDN which prefixes do you prefer are using which clusters inside your network. So they will respect MED or longer prefixes or longer AS path. Some will not. It's a little bit different, so you have to look into the individual CDN before understanding completely what kind of control is put into your hand. And mind, this is only a handful or a smaller group of the CDNs that allows you to do that kind of signaling or that kind of manipulation of the traffic. And again, here we're looking at prefixes sent from the ISP to the server. A very common method by most of the CDNs is using the DNS server that the end user is using to ask for their content as a mapping mechanism from to steer the end user to a cluster or a server or a location. So they basically build up a DNS server map where the clusters is assigned to, and then when a user is using that DNS server to request content, it is directed to the specific cluster. Some are using Anycast. So we all know the server has the same IP address, and your internal routing decides where do the requests go. And finally, a lot are relying either as a fallback or as part of the decision process is the geolocation of the IP address by the end user or maybe by the DNS server. Right. Okay. Quick recap on this is how a very BGP centric CDN is working, and this one I think I can say this is Netflix, one of the CDNs I know the best. And basically, short is that cluster A has 124/24 assigned to it or announced to it. The other cluster has a different /24. And then the end user that belongs in the number 2/24 is asking the CDN, hey, give me this movie. And then the CDN is looking up in their internal table and say, hey, go to cluster B and you will get your movie. Quite simple, works well for most in most cases. And when it doesn't work well, they fall back to geolocation. Quick recap on how a more DNS-specific CDN works. If we start with one, there's a user in Mumbai, in India, asking, hey, DNS, hey, give me this site.com, where can I find it? And then the local DNS server asks the authoritative DNS server, hey, where can I find site.com? Well, site.com is site.cdn.something.com. And then the local DNS server asks the CDN, hey, where can I find site.com, CDN, something.com? And then they told me, hey, well, for you, DNS server, that site is go to site number A, and then the end user is finally redirected to go ask A, hey, give me my content, and it gets the content. Very brief, probably a lot of more magic going on there than in this, but it gives you an idea about what is happening. But there's more to the story than just, because the question comes up, well, how does the CDN then decide? So this was just how is the end user being told about where to go? And the CDN, before we talked about, it was some BGP assignments, some DNS mapping, but the DNS mapping is based on more criteria. So there are criteria that they apply in their decision algorithm is latency measures. Some of the CDNs are measuring latency all the time to the DNS servers that they know their end users are using, and is using those measurements to decide whether to send the end user to site A or B. Some are also looking at what is my connectivity to that end user. Is it using my transit or peering or public peering? And they do have a preference from using the private peering or the embedded private peering, public peering, and transit. So that is taken into account as well when the user is directed around into which cluster it needs to go. And finally, some of them who have written their clients themselves, also using signals from the client to decide where they want to go. Then they also take into account, well, how much is the load on the servers out there going right now? So they make sure they're not sending too many end users to a location or a server that is already very busy, but send it to another one that is less busy. And finally, they also have to look at where is the content. We're going to look at how content explained is placed on the servers in some of the next slide. But what you need to be aware of is that not all content that is served by this CDN will be on the embedded servers inside your network. Some services are not even offered to embedded servers. Services, when I talk here, or some products, is product aimed at the content owners. They may decide that they do not want to have their content deeply inside somebody else's network, but want them in more secure POPs that are owned and operated by the CDN themselves. Others is like with movies, maybe the popular movies, it doesn't make any sense to put that into the network. They will stay on large centralized sites where there is enough disk space to hold them. So again, you can never expect to have 100% of the traffic going to the embedded servers because the CDN have made decisions that that means that that will not happen. Okay, so I was talking about different ways of placing the content on this on the servers in the CDN. And here again, I'm starting with Netflix. And what we see here is a typical traffic profile over a week for an ISP who has a well-designed Netflix setup. And the blue tall one, I'm going to point over here. Yeah. So the highest peaks is the traffic coming from the embedded servers to the end users. So we are very happy about that. It's peaking in the evenings where people are sitting down in their sofa and watching movies. We see there's a small peak, the green one, going in at the same time. And that is the long haul. Those are the movies that are not very popular, which means that they are being served from larger centralized sites where they have room for that movie. And it doesn't make sense for the CDN to put that movie inside your network because only 5 people are going to watch it. And then, well, how do Netflix put the movies into your network? They do that in what they call is the fill window. So they calculate every day, this is what are going to be popular tomorrow. And then they put those movies that are going to be popular in your network, they're loading those into your network with the red little spike, because they're trying to only do one copy of each file over the network edge. And then the yellow spike you see there is then the traffic going from that one copy. The rest of the servers inside this ISP's network is then fetching that file from the first server that got it. So that's basically how their fill algorithm is working. The benefit for somebody who embeds Netflix servers this way is that they have very little traffic coming over the network edge. So it's a good idea if they have expensive traffic coming over their edge. If we look at a good designed Akamai setup here, again, we have embedded caches to the end users. And then we see a higher green spike here, which is traffic from outside the network to the caches. And this has to do with the way that content is placed on Akamai servers, which is what a lot of the other CDNs are doing as well, which is a push functionality. So the user is directed to a server saying, hey, give me content. If the cache does not have the content, it goes back and asks from outside the network, hey, give me content. Content downloaded to the server and then to the end user. And then it's present on that server for the next user to ask for it. Works well, you can see with the blue spike coming up. And then they have a sort of constant amount of traffic coming from outside the network to the end users, and I am very, very late. And that is basically you see that is the content that will never get onto the embedded servers. I'm going to go quickly over Facebook, because it's the same model of placing the content. They will have a little bit more type of content that is not going onto the embedded servers ever, and which is why you see the graphs are a little bit higher. You can study them in detail in the slide later on. And what to think about with Facebook is that Facebook has a lot of static content, but they also have a lot of content that needs to be globally consistent. And that is the content that will not go on the embedded, but needs to be synchronized. And that is the between all of their sites. And that is the feed, the news feeds and the likes and anything of that kind of thing. Quickly going to go over this because I already talked about it. What you announce to the CDN or to the individual server is also turned into an access control list. That means that this is the only IP addresses that are allowed to get content from that server. Okay, and why do we need to care in so much detail about this? Well, we need to care if first of all, we need to care if it doesn't make sense for us to deploy embedded caches at all. And there's the business case about saving traffic on your network edge. But also, if you want to deploy deeper into your network and put it very regionalized setup where you have a lot of sites with embedded servers in, you need to understand how the end users are steered to the cache. Because, for instance, when the CDN is using your name server, your DNS servers to map the end users, if you only have one or two DNS servers clusters that your end users are using, but you want to put servers out on 5 different locations, the traffic will not necessarily be mapped into, and you have user groups assigned to each of those 5 locations. Some of those user groups will be using the same DNS servers, which means that the traffic will be going crisscross across your network anyway. So these are things to be mindful about. Same with if you're looking at Netflix and you're looking at the BGP prefixes, if you haven't regionalized your user groups into big prefixes that you can announce to the servers, it doesn't really make a lot of sense to deploy them deep into your network because, again, a user will be mapped crisscross and traffic will flow across your backbone links anyway. So things to think about. We cared a lot about the hardware 10 years ago. Really, right now, I don't think you need to care a lot about the hardware from the CDNs. It is always very new hardware. It is very small these days. It's very high performance. It will need power, but you can get the type of power that you want to get. And usually it is very efficient compared to at least what it was 10 years ago and compared to your network gear as well. So once you decide that this is something you want to do, I don't think caring about the hardware is a big thing. It is actually more about where does it make sense to put the servers. So, very short conclusion. It was unpredictable. I got angry 10 years ago. I don't think I'm that angry today if I was working at an ISP and wanted to deploy it, because what I see also from the talking to people and looking at the material from the CDNs, that is, the processes are working more smoothly than they did. And again, you can get customized to your power needs. But one thing that's still a challenge is the different ways that they map the end users and the different ways that they steer and place the content. But once you understand that, you can build yourself a setup that works for you, and you can offload a lot of the traffic from your edge onto the embedded solution. So finally, am I right? I'd like to hear if anybody want to share their experiences with embedding servers, or if I have some massive errors in my presentation, please point them out as well so I can learn. Yes?
Thank you. I've got one here. Thank you, Nina, for a great talk, as ever.
Hi, this is Alexi from Finland. So some of those CDNs also use the CDN system for streaming, like live video feeds and stuff like that. Did your data have that, or did you filter that out?
Oh, what services are used?
Yeah, what services?
What services are running? I have not looked into that. I know what some of the, in particular, the specialized CDNs are using. Like Netflix, we all know that is movies, right? But no, and I don't have access to that information in the data set that I do have. I think the limitation is too big, so I can't answer that. But we actually do have the ability to map that kind of traffic and look at it, and it's a good suggestion. Maybe I should dig a little bit deeper into that and add some slides for the next time.
My point about it was that for live streams, the portion of traffic coming from out of the off-net to the caches compared to caches to end users will be different than static content.
Okay. Yeah. No, I do not have that data.
In the back.
Hi, Jan from Norlys. I can confirm that things are getting easier, but still everyone is doing it slightly on their own way. You mentioned a lot about hardware. I think I should comment that some CDNs, they ship kind of the specialized hardware that was developed for them. I think we can, now you're public talking about Netflix, we can mention them. But there's also some others that ships off-the-shelf hardware, often managed by some third party, and that actually causes us a lot of issue. Because, for instance, if we have a power supply that is dead, then some guy just shows up in front of the data center, wants to get in and replace that. So at least some of the CDNs, they have a lot to learn how those managed service providers should work with us as ISPs. That is causing a lot of grief. Another thing I would like to comment is that, at least to my knowledge, Microsoft does not provide any hardware. They do provide like an ISO image. So if you want to have an embedded Microsoft cache, you can go out and buy the hardware yourself and deploy that. Again, looking at your data, of course, you cannot see who owns the hardware, but sure. Just to comment on that. If there's time, I would like to ask the statistics you showed about traffic coming in over the edge and from the embedded. How did you get those data? Because I would assume that the majority of your customers, they will send NetFlow data from the edge of the network. But a lot of service providers tend to embed the caches into the data center and probably not send flow data. Did you do that based on DNS?
No, it's not based on DNS. It is based on the classification of interfaces that the customer. So the data I have is Kentik customer data, and what our customers can do in the tool is to classify their interfaces, and one of the classes is embedded servers. So it's basically using traffic coming from embedded servers classified interfaces. Of course, there might be errors in the way that people are classifying their interfaces, so there is some uncertainty on the data set that way, but this is the best I have.
Okay, we're running a little late, so we probably have to say stop now.
But I mean, we are out here. If you have any questions about embedded CDNs or Kentik, come hit us up in the break.
She's here all week. Tip your server. Thank you again, Nina. Great talk.
Thank you. Oh, chocolates. Awesome. Thank you.